Good morning, folks. Thanks for the opportunity to present here. So the ONNX Model Zoo is a place that we all know and love, and is the place for downloading ONNX files for all users and application developers. So now, what's with this new ONNX Model Zoo that's powered by ML Agility? Like, what does that offer? So we want to start with an improved developer experience. Currently, the Model Zoo is based off of the GitHub interface, where you can look through models and download from GitHub. So we are improving the developer experience to navigate, look for models, filter through models, and search for the specific model that you want and download those models. And we are 10xing the number of models that the Model Zoo currently contains. And we are moving all of the models to newer offsets. And not just that, but we're also adding the ability for the entire Model Zoo to keep up with incremental offset updates so that we always have access to the latest models. And all of these capabilities are being powered by ML Agility, which is a benchmarking suite for 1,000+ models in an automated way where you can target a range of hardware options and different software stacks. So given that, I would like to introduce ML Agility and dive a little deeper into what the thesis of ML Agility is as we go into how that serves the new ONNX models. So to start with, one thing that all of us can agree upon is that we live in a maze of hardware and software options for AI acceleration. And given these range of options, the question often is, what is the right choice? Like, what is the right metric? Performance, latency, throughput, perf per watt, perf per dollar. There are a bunch of metrics, and how do we choose this? So ML Agility is here to answer this question. But you may ask, do we already have a bunch of tools that answer these questions? So what's different with ML Agility? So to start with, it helps measure the turnkey performance of different hardware and software options for a range of models. And in most cases, turnkey performance is equal to the deployment performance of models. And this provides a diverse ecosystem of models, like I mentioned, 1,000+ models across different ranges of use cases, tasks, and model architectures. And the curation of models here is completely vendor agnostic. It's not curated in any way, shape, or form. Anybody can add models to this. Right now, we're literally just scraping models of the web. And last but not the least, benchmark results. So this is intended to serve as a complementary benchmark to MLPerf, where MLPerf has a tight set of models that does encourage people to develop custom kernels for those models, and the performance of MLPerf is not reflected on models that you see outside of those list of models. Awesome. So I'll dive into the architecture of ML Agility. So like I mentioned, we have a curation of open source models that have been sourced from all of these libraries. There is no specific reasons why these were chosen. We could go ahead and add a lot more libraries here, all the way from Torch Hub to PyTorch Geometric for GNNs. And all of these models go through an automated export flow where these different frameworks get automatically converted to ONNX. And now that you have an ONNX file, which is the common playground for all of these models we have here, you have two options. You could either push them to the cloud. Currently, Azure and GCP are supported, or you could choose to benchmark them on your local system on site. And the options that you have are, these are the things that we currently support. You could use an option of ONNX MLAS or PyTorch for benchmarking on x86, and the latest TensorRT containers provided by NVIDIA for the GPUs, Grok Flow for the Grok chip, and AMD ROCm support is a work in progress. And as you can see, adding more runtime options and more hardware is very straightforward, as this is built in a really modular way. And once the benchmarking is done, all of the benchmark results are being made available for a lot of these models on a publicly visible Hugging Face space. So just jumping a little deeper, we do exactly have around 1,853 models ranging across all of these different libraries. And there is, for example, on Hugging Face, we just sorted the list of models by the number of downloads and picked the top models. And there's no reason why we cannot add more models to this. And we also provide the benchmarking tools. The first form in which the tool is available is an API, where all you need to do is just add a single line of code to your existing Python script, where the API is called benchmark model. You just pass it the model instance that you already have, some example inputs, and you get to choose the device from the range of options that I showed. And ML Agility goes through these set of steps. It exports it to ONNX automatically in the backend, optimizes it using the ONNX runtime optimizers, converts it to FP16, and finishes up with the performance numbers. And benchmarking on different hardware options is just as easy as passing in the right parameter through device. And there are more runtime options, more command line options available as well. So let's say you don't want to open your file at all. And that's where the CLI tool comes in, where you don't have to open your Python file at all. You just pass your model file, which is, for example, a Hugging Face model card, to the CLI, and the CLI takes care of the rest. This is the same operation where you pass in your Python file and choose the device you want to benchmark on. And there are more options that will help you choose between cloud or local and what is the runtime you want to use. For example, on x86, you could use PyTorch, you could use MLAS. By default, we go through ONNX runtime MLAS, and it goes through the same set of steps, benchmarks the model, and gives you a location on where all of the files that related to this are stored. And all of these results are being exposed on a Hugging Face page. And again, to quote, it's completely vendor agnostic and open source, and it's extensible through more runtimes and accelerators by just the modular interface that we have. So given that we have this modular and automated interface, let's say the Hugging Face spaces results are not the only, it's not just the spaces that's of interest. We realize that there are a lot of other places in this whole architecture that could be used for benchmarking and measuring the efficacy of tools. For example, Microsoft is working on a new PyTorch exporter, and we could just plug that exporter into this to measure the efficacy of that exporter compared to the existing exporter. And now that you're able to run it through thousands of models, you could exactly pinpoint where problems are and what needs to be improved to make the whole ecosystem better. We have teams looking at comparing different CSPs. You could just rent out the same accelerators, rent out the same NVIDIA hardware on Azure and GCP, and see what is the ground truth performance you get and compare the CSPs. And just like this, we also have, given that we have a range of models and we know which of these models can currently export to ONNX, we just be exposed to the community as the new ONNX Model Zoo. So what you see here, I'll go through a demo. Okay, it's a live demo. What could go wrong? So this is the new is the prototype of the new ONNX Model Zoo that will be rolled out. And what you see here is a very simple two-tabbed interface. The first tab is a list of ONNX models which are sourced from the GitHub LFS that we have currently, and it gives you the ability to filter down to specific use cases that you want, search for specific models, and just by a click of a button, you will be able to download the ONNX file to your local disk. GitHub LFS is rate limited, so we do see a lag in the download, which will be fixed. And the other tab that you see is the Python model cards, which is the list of 1,800 models that I showed from ML Agility. So in this interface, you again have the same way to search for models, search for specific files that you're looking for, or narrow down to specific use cases. And by just clicking on the file, you'll be able to view the source of that model card, on how that model card is built. And these models are not built by us in any way, shape, or form. This is just sourced from the existing open source libraries. And as you scroll down, you'll see a set of steps to export it to ONNX. And just by running these 4 commands, you'll arrive at the .onnx file for this particular model. So this is the updated interface that we are working on to be rolled out as the ONNX Model Zoo. And going back, come on. Yes. So all of this effort of ML Agility is open source and completely available for public access on GitHub. I know this is being recorded. I'm not going to ask you to like, share, and subscribe, but definitely watch, fork, and star the repository. Thank you for the opportunity. Any questions?
Well, I have one.
Yes.
So you said about benchmarking.
Yes.
How does vendors, hardware vendors especially, contribute and be able to ensure that the right combination, right ingredients are used and benchmarked?
So for all of the runtimes that you saw, like TensorRT and MLAS, we always pick the latest that's available. If a new hardware vendor wants to add their hardware to this, they just have to create one file that will say where they're pulling the software stack from, and an endpoint where we can access the hardware. It could be an IP on the cloud or a local system.